We're going to be doing a merge sorted array. The question states, you are given two integer arrays, nums1 and nums2. Both arrays are sorted in non-decreasing order, which means that it's going from lowest value on the left to highest value on the right. These arrays have two integers, m and n, representing the number of elements in the arrays respectively. We're going to be merging nums1 and nums2 arrays into a single array, which is also going to be in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1, which means that this is going to be passed by reference. We're going to be sorting in place and changing the array itself. To accommodate this, nums1 has a length, so length nums1 of m plus n, the two integers that were previously stated, here and here. Whereas the length of nums2 is n. The last elements of the array are going to be set to 0 of the nums1 array, and they should be generally ignored. Now, the question is, how do we start this problem? Well, we're going to need an iterator to be able to compare the values between nums1 and nums2 so that they'd be able to sort it in a non-decreasing order. But the question is, do we start sorting from the beginning of the array or from the last value that is non-zero for both arrays? And in order to answer that question, we have to think about what the advantages and disadvantages of both are. If we were to start with a pointer looking at the first element of each array, then we're going to have to sort the array for every instance to make sure that it's in the proper position. Whereas if we were to compare the very last element between the two arrays, then we can just append it to the very last element at n plus n minus 1, because the indices is starting from 0, and just append it there and continue moving on. And so if it's going to be an iterator, then how do we know when to terminate? Well, when both m and n are equal to 0, then we know that we've gone through every element of both arrays. And so what we can do then is create a while loop where m is greater than 0 and n is greater than 0. Now, we have to think about the conditions to compare, and we've already stated that we're going to be making a pointer located at the very last element of both arrays. And so in the event that the element at the very end of nums1 that possesses an actual value that's non-zero is greater than the last element of nums2, we can conclude that it would go at the very last element of nums1 m plus n minus 1, because given that both of these arrays are sorted, we can state that whichever value between these two arrays is greater will be the greatest number in the merged array when we conclude and have gone over every other element. And so the comparison would then be nums1, m minus 1 is greater than nums2 at n minus 1. And we can say, well, nums1, m plus n minus 1 equals nums1, m minus 1. Because, again, this value is the greatest value between these two arrays. And once we've done that, we can state that we've already looked at this element, we've already compared it, we've already moved it, and so we can just decrement m to look at the next highest value within the array. So that would just be m minus 1. But what about every other condition? Well, if in the event that this number here, or whatever m is currently pointing at, is less than 6, then we can just say, well, nums2 should be going at the very end of the array, which would just be nums1 m plus n. So the beginning is the same, but instead of nums1, we do nums2 and n minus 1, and then we just decrement. But you might be asking, in the event that we've decremented everything in nums1 to the point where m is now 0, but there are still elements in the second array in nums2, what do we do then? Well, what we could do is just create another while loop, just to make sure. And that would look like this, where we say, well, n hasn't been decremented fully, so n is still greater than 0, and then we just go nums1 m plus n minus 1 equal nums2 n minus 1, and we just continue decrementing until it's 0. And that should conclude our algorithm. And if we were to test the run speed of it, and note that the run speed might vary depending on to whenever you're iterating. So currently it says 8 milliseconds, but if we were to submit again, it'll vary. And so this concludes how to solve the merge sort array.